Compute the limit as x approaches 0 of the secant of x minus 1 quantity over x cubed minus x squared. So if we plug in 0 for x, we get the secant of 0 minus 1 divided by 0 cubed minus 0 squared. Now the secant of 0 is 1 over the cosine of 0, and the cosine of 0 is 1. So the secant of 0 is also 1, and we get 1 minus 1, which is 0, divided by 0 minus 0, which is 0. So we get the 0 over 0 indeterminate form, and L'Hopital's rule says then that this limit is equal to, and we take the derivative of the top and the bottom separately. The derivative of the top, the derivative of secant x, is secant x times tangent x, and the derivative of the bottom is 3x squared minus 2x by the power rule. And there should have been written here, limit as x approaches 0. So now plug in 0. On the top we get secant of 0 times tangent of 0. And on the bottom we get 0 minus 0. The secant of 0 is 1, but the tangent of 0 is 0. And so this is 0 over 0 again. And we can use L'Hopital's rule more than once. So we will use L'Hopital's rule a second time. We will take the derivative of the top and the derivative of the bottom. And actually, to simplify things here, let's look at this numerator. The secant of 0 is 1. So what we're going to do here is we're going to use a limit law that says the limit of f of x times g of x is equal to the limit of f of x times the limit of g of x. The limit of a product is the product of the limits. This is one of the limit laws. So we'll split this one up a little bit. Let's take this limit of secant and put it separately, because we know the limit of the secant is 1. And also on the bottom, if we look at 3x squared minus 2x, if we factor out an x, that's x times 3x minus 2. And the 0 on the bottom is coming from this x. So let's put the 3x minus 2 here. So this limit is not 0 over 0. It's going to be a number, a non-zero number over a non-zero number. And then we will multiply this by the limit as x approaches 0 of tangent x divided by x. So we really didn't use L'Hopital's rule just yet. What I'm doing here is, since our numerator and our denominator are a little bit complicated, I'm actually splitting off part of it here that is not going to give us a 0 over 0. In fact, this is going to give us no trouble at all. It's just going to be a regular old number. And then we'll have this one, which will be 0 over 0. So we get, I'll put L'Hopital's rule here because we're going to use L'Hopital's rule on the second one. Actually, let me just clarify that right now. If we plug in 0, the secant of 0 is 1, and 3 times 0 is negative 2, so that's negative 1/2 times 0 over 0. So this one requires L'Hopital's rule. So we get negative 1/2 from the first limit, and then from L'Hopital's rule on the second limit, the derivative of tangent is secant squared, and the derivative of x is 1. This limit is 1 squared over 1. So we have negative 1/2 here times 1 squared over 1. And the answer then is just negative 1/2. So the lesson in this example is that we might have to use L'Hopital's rule more than once. And if our fraction gets complicated, then we can just split the fraction into pieces where part of it is not 0 over 0 and the other part is. So again, this fraction, we could write it as secant x over 3x minus 2 times tangent of x over x. If you multiply these two fractions together, you multiply top times top and you get this numerator, and you multiply bottom times bottom, and when you distribute the x, you get this. So we split this fraction into these two pieces and take their limits separately according to the limit laws, so that we have the limit of the first fraction, which is just negative 1/2 by just plugging in, and then the limit of the second fraction, that one required L'Hopital's rule because it was 0 over 0, and then it gives us just 1 over 1. So the answer was negative 1/2.